Welcome to the first module from Environmental Geography. This module covers the first chapter, Living with the Earth. And I am Nathan Bowden, your instructor. In this module, you will learn how environmental geography touches your life, how human population, consumption, and technology impact the global environment, costs and geohazards such as earthquakes and floods, Earth systems defined and how they function via interaction, how science works, and lastly, the meaning of sustainability and why we should strive for it. Themes of this text are how people and Earth interact, how Earth systems interact with each other, and how science helps people to understand and deal with issues related to Earth. Lastly, how people can take steps to achieve a sustainable future. The human environmental impact depends on how much of Earth's resources are consumed. As you see on the right-hand side, there is a dam which has two purposes. The first is as a source of drinking water, and the second as generation of power. This also depends on the amount of generated waste, quantity, and the process of resource consumption. Sustainability, if you haven't already heard, is one of the critical concepts in environmental studies, and is one that we will use as a measure throughout this course. It is in essence the capability of the human impact being continued with minimal long-term effect on the environment. On the right-hand side, in this picture, you see an experimental agriculture station in Peru, which is using very sustainable farming techniques. Some important factors to consider, of course, is the growth in human population. And on the right, you see a city in India, which represents the fact that at this time, more than half the inhabitants of the Earth live in cities, and this proportion is increasing. The amount of resource consumption that the human population in the cities, but also in non-urban areas have, the technology factor, and of course, Earth's impact on people. We must not ignore the impact that the Earth has on us, and not to focus only on our impact that we have on the Earth. The US Census Bureau estimated that by 2050, the number of people on Earth will be approximately 9.5 billion, and that's 40% greater than it was just a few years ago in 2010. The global resource consumption varies throughout the globe. So on the left-hand side, you have a family in rural India with all of their possessions outside of their house, and their house is not too huge. And on the right-hand side, you see a picture of an English family in the suburbs, and their resource usage is considerably higher. 2 cars, a much larger house, a lot of electronics, clothes, furniture, etc. While the Indian family has basically 1 bed, a bicycle, some pots and pans, and grains. Energy is a very important resource, and much like the material resources, energy is also not the same around the world. The average citizen of the United States uses 20 times as much as a citizen of Ghana and 46 times as much as a citizen of Bangladesh. This in itself is not a bad result if the consumption of energy in the United States and in the West is renewable. But of course, at this time, it is not. Even as growth rates of the human population slows, but numbers are still increasing, the consumption patterns, including energy, will become an even more significant aspect of human environmental impact. Technology factor and choices in growing cities. Some of the choices include municipal wastewater can either be dumped directly into the environment, rivers and oceans, or can be treated and recycled. Transportation can be used either via the roadways or through mass transport systems such as subways, buses, and trains. Solid waste can be dumped into landfills or in some cases the ocean, or rather it can be incinerated and recycled. Which choices will people make and why? Choice of a technology and environment. On the left-hand side, you see a picture of two cars, one a Humvee, a white Humvee, and on the right next to it is a red smart car. And the question is, which of these two will most negatively impact our environment? On the right picture, you see a very large amount of refrigerators were sitting in a landfill. And the question is it better to buy a new refrigerator, which has a much higher energy efficiency, or should you hold on to your old refrigerator, knowing that if you get rid of it, it will just end up in this landfill? This question is more difficult to answer. Impact is defined as the population multiplied times the affluence factor, and then also the technology. Now we've looked at the impact that humans have on the environment, but we should also look at the impact that the environment has on humans as a direct relation of humans expanding and getting closer to these natural disasters. In general, they can be grouped into three varieties: volcanic eruptions, earthquakes, and landslides. But we must also not forget floods, etc. Increasing amount of federal tax dollars, both in the United States and the European Union, are being spent to deal with the impacts of natural disasters. On the left, you see the amount of tax dollars being used in the United States in the last 50 or 60 years. And as you see, this has greatly increased. A good example is the natural disaster of the Hurricane Katrina in New Orleans, which cost the United States approximately $200 billion in property damage and loss. More recently, Hurricane Hugo landed on the northeast of the United States, impacting New Jersey and New York. And there, the estimation at the last was at 90 billion. There are four systems that interact at the scale of the entire Earth. These are the geosphere, the atmosphere, the hydrosphere, and the biosphere. The goal of this book and this course is to help you understand how and why Earth changes from a systems perspective. A system is a group of interacting, interrelated, or interdependent parts that together form a whole. An example of this is the carbon cycle, a cycle that you've probably already been exposed to. The carbon interacts between these four different systems: the atmosphere, biosphere, hydrosphere, and geosphere. And at one time, they are locked within the system, and at the same time, they also interact between the systems. So here you see the interaction from the atmosphere to the hydrosphere is approximately 92 billion tons per year. However, the atmosphere holds in total 760 billion tons of carbon, which it receives again through the hydrosphere, the biosphere, and the geosphere. There are basically two different types of systems: a closed system and an open system. A closed system is one that exchanges only energy with its surroundings. The entire Earth is an example of a closed system. An open system not only exchanges energy, but also matter. So these four spheres are examples of open systems. A reservoir, so we can see these four systems as a reservoir, and then we could also see it as a lake, are affected by the flux in and the flux out of the system. If the flux in is the same as the flux going out, then this reservoir is considered to have a steady state. If the flux in is greater than the flux out, this reservoir size is increasing, and vice versa. If the flux out is greater than the flux in, the reservoir size is decreasing. If transfers of energy and matter into and out of an open system are about the same, this system is said to be in a steady state, as shown in the figure on the right at the top. Related to the flux is the residence time of the reservoir. Transfer between reservoirs constantly is taking place, making, for example, carbon atoms home seem to be a moving target. One measure of how matter, such as carbon, is exchanged is through residence time. Residence time is defined as the size of the reservoir divided by the flux in at a steady state, which is to say the same as the reservoir size divided as the flux out at a steady state. Changes in one part of a system can affect another part. An example of this is the rain in the distant mountains can cause devastating floods many kilometers or miles away. Seemingly localized or small changes can in combination develop into broadly significant ones. This is often called the butterfly effect. A great strength of science is that it aids our understanding of how seemingly unrelated events can impact or connect, in short, how systems work. Science helps by helping us better understand and solve problems, such as predicting volcanic eruptions or when landslides will occur or other possible hazards. And our goal of this course is to develop your understanding of how science can be part of your everyday decisions and how they impact the environment. The scientific method is an iterative method. We begin with the observation of data, and with this we form a hypothesis to explain these observations to form a hypothesis. Through the hypothesis, we make predictions based on this hypothesis. The predictions we can then test and then gain new observations. If we think that we need to refine, revise, or to replace the hypothesis, we would do this, again, make new predictions, test these predictions, until we are satisfied, and then all these observations put together, confirming the predictions. If this is the case, then the hypothesis becomes a theory. This is what we call the scientific method. Science can be used to address some important human-environmental interaction issues, such as the availability of water, transition from oil to other energy sources, such as renewable energy sources, and the global climate change. How to achieve sustainability in the future? Human population is using land, depleting resources, and lowering environmental quality around the world. Renewable resources such as solar power or wind are ones that will continue to be available because they naturally replenish as fast or faster than they can be consumed. Non-renewable sources like oil or coal are those that are not replenished as fast as they are being used, and in this case you can see that the flux out is greater than the flux in. Therefore, there must be a balance between resource varieties and consumption. The future must be sustainable. One of the considerations for aiding global sustainability, in which we have not talked about yet, is the maintenance of biodiversity and understanding carrying capacity. An example is on the picture on the right, is a chart of a small island versus a large island and the amount of human resource consumption. On the one axis, you have the area of the island in square kilometers, and these are the islands within the Hispaniola chain, so Cuba, Jamaica, Puerto Rico, etc., Saba. The smaller the island, the less the number of species will be on this island. We can then extrapolate this to humans. The smaller the island, the smaller the number of humans can live on this island. To show an example is the island of Easter Island, and which is a cautionary tale. Easter Island is situated a few thousand kilometers off of the coast of Chile in the southern Pacific Ocean. This island is well known for its very large statues. This island used to be a very lush island filled with plants and animals. It was settled by Polynesian settlers thousands of years ago. However, the population grew too great for this island, and all of the resources were consumed. This had disastrous effects for the residents of this island, of which most died of starvation. And when Europeans discovered the island on Easter Sunday, there were very, very few people left on this island, and the island was a barren island. We must see this as a cautionary tale. If we consume the resources at too great of a rate, at a certain point, it will no longer be able to sustain a human population. In summary, the Earth is like an isolated space capsule, a closed system, and people have become key factors influencing its environmental conditions. Earth has 4 interactive systems: the atmosphere, hydrosphere, geosphere, and biosphere. Earth's open and dynamic systems interact by exchanging energy and matter among them. We saw this in the carbon cycle. People affect Earth on a local and global scale. This study is called environmental geology or environmental science. Increasing population and consumption are global challenges, and we must also address biodiversity, pollution, energy sources, and the cost of natural disasters. I give to you for your consideration a few web resources if you'd like to look further along these topics. Thank you for your attention, and I'll see you in the next module.